Okay, third question on iteration. It says show that the equation has a root alpha between 0 and pi over 8. Okay, now it's really important to remember, okay, when you have iteration questions involving trig functions, you have to put your calculator in radian mode. Okay, so the good thing is that's the case for every question on iteration, right? If there's trig involved, it's radian mode. So you press shift mode and then you press 4 then for radians. Okay, if you don't do that, you won't get the marks. So to show that there's a root alpha between 0 and pi over 8, remember now you label this as a function, okay? So we've got it equals to 0, okay, but call it f of x, right? And then you put in those two values. You put in f of 0, okay, which will be 2, take away 10 times 0, plus sine of 0, okay? So you can work that out in your calculator. 2 take away 10 times 0, plus sine of 0, okay, which comes out to be 2. Alright, do the same then for pi over 8. Okay, so you put 2, take away 10 times pi over 8, okay, that's what your x is becoming, plus then sine pi over 8. Okay, so you've got 2, take away 10 bracket pi over 8, okay, plus then sine fraction pi divided by 8, oops, not like that, we're going to get it on a fraction there, close bracket, and there you go, so you've got minus 1.54430 and so on, right? Now you can see here, one is positive, one is negative, so there's a change in sign. So once we've shown that there's a change in sign, we can then say therefore alpha has a root between 0 and pi over 8. We've shown there's a change in sign, so basically the result when it equals to 0, okay, the x value when it's equal to 0 is between 0 and pi over 8, okay, and they've called it alpha, so they usually do. Okay, so then we go into the recurrence relation, right, which is set up for us. X0 is 0.2, find and record values for x1, x2, x3, x4. So x0 is 0.2. Okay, so we want x1, x2, x3, and x4. Okay, and what's good here, of course, we've got basically got the formula there given. So if we put 0.2 equals, okay, so that's our answer. And then when we set up the formula then, 1 over 10 bracket 2 plus sine ants, okay, so it uses the previous answer, close bracket there, so press equals, and I get for x2 0.2198669331. Okay, so write it all down, importantly write it all down. Press equals again, using the previous answer now, it would be 0.22180999761. Press equals again, 0.221999566, okay, and then press equals again, and I got 0.22201805553. Okay, so that's my x4. And then it says write down the value of x4 correct to 5 decimal places. So then I can say x4, therefore x4 equals 0.2220, and that would be 2, wouldn't it? So because that 8 means I have to round that up. Okay, so that's the 5 decimal places. Okay, now and then it goes on, of course, to say then prove that this is the value of alpha correct to 5 decimal places. Right? What you're going to do then, of course, is recognize that that's what we're looking at as our answer to 5 decimal places. Okay, and if we put here 0.220, oh, missed the 2 there, haven't I? 0.22202. Of course, the next value to 5 decimal places would be 0.22203, and the one before it would have been 0.22201. Okay, that would be the case. That would be like our 5 decimal place number line. Now what we need to do is to check the one in between, halfway in between. Okay, so if that's O2, that's O3, it would be 0.222025, and that one in between there, 0.222015. Okay, so we check those two values there in the middle. Okay, and remember then you always go back to your original f of x. Don't put these values in your iteration formula. Okay, don't put it into that. Put it into your f of x. So f of the first one, okay, 0.222015. If you put it into your f of x, which remember now is up here, okay, that one there, this will be 2, take away 10, 0.222015, okay, plus sine of 0.222015. So I work that out. Oh, I missed the other 2 again. My calculator. Right, so that's right now, isn't it? Can you check that's right? Yeah. Okay. Plus sine 0.222. If I'm wrong, just tell me. 0.15. So I think that's right there. So when I type that value in, I get this out. So it's 4.56. Again, standard form, right? Often comes up like this, times 10 to the minus 5. It's positive though, right? That's important. Remember that negative power just means it's a really small number. So this should be like 0.0000456, I think. But there's a positive there, isn't there? There's no negative, so it's positive. If we check the next one along then, okay, so we've got 0.222025. Okay, so we've got to chuck that in. I would always write down as well what you're typing in this case. So we'll write this down. Okay, but what's great then when you calculate that, right? There's less work to do now, so you just go back on the repeat button, replay button, go back and just change these to 2.5. And there you go, that's brilliant. So you end up with a negative there, don't you? 4.46 times 10 to the minus 5. So we've shown, right, there's a change in sign, therefore a change in sign. So 0.22202 is correct. So 5 dp. In other words, that one gives you a positive result, that one gives you a negative, so somewhere between here is the result, so it's closer to that 5 decimal places.